Broadcasting live from SETI Alpha 6 in the Andromeda Galaxy, this is Mr. C.
And it's happy downhill day. It's Wednesday, all downhill after today. Hey, you got 2 white sheets. Why is that? Well, we've got a little quiz. And I hinted at it, and so did Mr. Gilbert, I think. So, and then you've got a red pen out because we're going to grade the quiz, and then we have 2 worksheets that we need to grade, so we're going to be busy. So let's do the quiz first. If you'll number to 10 on your white sheet, number to 10. Name, date, period, upper right-hand corner, numbering to 10. Your lesson summaries are stowed for the moment. We will use them in a little bit. And you've got a word bank. Mr. Gilbert has put some words up there for you to use as a word bank. A word about the word bank. You are not, I repeat, not going to use every word in the word bank, but they're up there for spelling purposes, in case you need them. Run your eyeballs over all of those words in the word bank right now. Run your eyeballs over them. Take a good look at them. Maybe an answer will be up there to a quiz question. Maybe not. Okay, you've got your cover sheet now. So you've got name, date, and period, upper right-hand corner. You've numbered to 10. You've looked at the word bank on the board. And number 1, the planets follow this kind of orbit. It's where you have a flattened circle. It's not a circular orbit. It's a flattened circle. That's the shape. What's the name? Number 1. Number 2, what do we call a sun-centered solar system where all the planets go around the sun? Well, don't they actually? Yes, they do. What do we call that? A sun-centered solar system. Number 2. And maybe Mr. Gilbert is writing these down too, just in case he needs to give you a little bit of help. We'll see on the time to get you ready right before we grade it. Number 3, what do we call an Earth-centered solar system? The Earth's the center. It's the way things started out with Copernicus many, many centuries ago. Number 4, what do we call an environment where all of the matter is gone? It's empty. No atoms, no matter. What's the name for that? Number 4. URLOs, stay with me on this. You should have gotten ready to go right away, and you should be working with me. And you need to send me this after we grade it. Number 5. By the way, you RLOs need to send me tests that you've taken from home. I need to see them. You need to send them to me in teams. Okay, number 5. What do we call a condition of space? Number 4 is like that. And number 5, where astronauts are weightless. There's a term for that. What do we call it? Number 6, what is the term for, well, I'm going to have you tell me. I'd like you to write down for number 6, 1, if you'll write down 1 AU, capital AU, and then I want you to explain what is 1 AU. So write out an explanation. What is it? Does this quiz count? You betcha. So number 6, 1 AU equals, and you are describing what it is. I'll repeat these in a little bit. 7 and 8 now. 4 characteristics of the inner planets. What are they like? The inner planets. Don't make it up. From our study, from your lesson summary, 4 major characteristics of the inner planets. My very educated mother. Mercury, Venus, Earth, and Mars. What do they all have in common? 4 things. Half a point each. Nine and 10. 4 characteristics of the outer planets. The outers. Just served us 9. Jupiter, Saturn, Uranus, and Neptune. What do they all have in common? 4 things, 9 through 10. 2 and 9, 2 and 10. Just short answers for 7 and 8 and 9 and 10. Repeats really quick. Keep your quiz covered with your cover sheet. Number 1, a flattened circle orbit. What do we call it? One word answer. Number 2, a sun-centered solar system. One word. What do we call it? Sun-centered. 3, Earth-centered solar system. What's the name of it? Number 4, an environment like space where there's no matter. 0 atoms. What do you call it? Number 5, weightless conditions. What do we call it? One word. Number 6, 1 AU. Explain what that is. An astronomical unit. I didn't want you to put down astronomical unit. I want you to explain what an astronomical unit is. 1 AU equals 7 and 8. 2 answers in 7, 2 in 8. 4 characteristics of the inner planets. 9 and 10, 4 characteristics of the outer planets. The outers. Okay, we're going to have a little break right here. It's a little early, but a little break for you to get any clarification from Mr. Gilbert. Keep your paper covered. No talking. See if Mr. Gilbert needs to help you at all. Okay, I'm back from that little break. So you've got that little break. Now let's correct the quiz. Red pens, initial down below. This is not an optional quiz. Everybody's turning it in. You've got your name, date, and period in the upper right-hand corner. Yes. All right, a flattened circle, what do we call it? An ellipse. An ellipse or elliptical. Number 2, sun-centered solar system, heliocentric. Number 2, heliocentric. Number 3, Earth-centered solar system. What would that be? Geo for Earth. Geocentric for number 3. Geocentric. Number 4, no matter, no atoms in an environment like space. That would be a vacuum. A vacuum. No matter, all the matter's gone. Number 5, weightless conditions, microgravity. That's what it's called, microgravity. Number 5. Now if it's wrong, mark it wrong, put -1. Number 6, what is 1 AU? Astronomical unit. Now you couldn't put down an astronomical unit. That's not the right answer. I said that. What is it? It's the distance from the Earth to the Sun. Now you've got to have the whole enchilada to get the whole point. The distance from the Earth to the Sun. We use it as a measuring stick. And we say that the planets are so many AUs away from the Sun. 7 and 8, the characteristics of the inner planets, Mercury, Venus, Earth, and Mars. They're small, they're rocky, or terrestrial, or solid, all of those. 3 possibilities are okay, but you can't use all 3 of them, just one time. That idea. They are slow rotators. They are fast revolvers, relatively speaking. They have few or no moons. And they have no rings. No rings, like the outer planet. Half a point each. You needed 4 of them. And then 9 and 10, the 4 characteristics of the outer planets. Kind of by contrast, just the opposite in a lot of ways. They are huge. They are not solid, they're made of gas. They're gaseous. So, made of gas. All of them have lots of moons. They all have rings. Some really prominent rings that are obvious, beautiful. Others, not much to them, but they still have ring systems. So they have rings. They are fast rotators. Fast rotators. Not that fast, but like 10 hours. That's fast. Okay. And they are slow revolvers. Slow revolvers. Takes a long time for them to go around the sun one time. Slow revolvers. Slow revolvers. Here's another one. I didn't tell you this one. They all have high winds. Because of their rapid rotation, it stirs up the atmosphere of gases. And they have high winds, so they have storms. So they have high winds or storms. Okay, I think I got all of them. At the end here, you could... Well, if you have a question, put a question mark by it. I'll look at it. Number right over 10 at the top. And pass it into the center, please. Into the center. Mr. Gilbert will gather those up. You've got your lesson summaries out. You're going to need them. Right now you've got 81F, worksheet 81F, and 87F out. We'll grade both of them. And if down at the bottom of the worksheets, if you will put your initials, your promise to me and the Lord that you'll grade honestly. Now, you know I'm going to look for page numbers. Each of these are going to be worth 6 points. All right, number 1 on 81F. This is models of the solar system. Have you got it? Have you initialed down below your promise to me and the Lord your grade honestly? Number 1, T for true. Number 2 is false. And instead of Latin, it's Greek. Helios is Greek for sun. Number 3 is false as well. An ellipse is an oval shape. We just did that. So far 1, 2, and 3, true. Greek, an ellipse. Number 4, Galileo discovered 6 moons around Jupiter. Nope. How many? 4. So number 4 is false, and the answer is 4. Number 5 is true. Ptolemy's model explained the motions in the sky of the planets and the stars. Number 6 is false. In ancient times, people could not accept that the sun was the center of the universe. That's true. The book is wrong. They couldn't accept a sun-centered idea. They couldn't accept that. They thought the earth was the center. I'll have to go back and check that. I'm going to leave myself a question mark. Okay, so that was true. Number 7 is D as in Delta. The guy who supplanted Ptolemy's observations, Tycho Brahe. D as in Delta. Number 8, Nicholas Copernicus. The arrangement of the known planets and how they move around the sun was first worked out by B as in Bravo, Nicholas Copernicus. Number 9, people became convinced the heliocentric model is correct. See, this was later, and by A. Alpha Galileo. Number 9, A. Alpha Galileo. Number 10, Earth is at the center of the revolving planets and stars in what model? That would be geocentric, right? C as in Charlie. Okay, each one is worth half. And then if you had all the page numbers, that's another point. So number right over 6. If you're not sure, put a question mark by it. I'll grade it. Okay, that's 81F. Now 87F, introducing the solar system. Here are the answers. Number 1, 1 day is the time it takes a planet to rotate on its B as in Bravo axis. Number 2, scientists think the solar system formed about 4.6 billion years ago. But it's not all scientists. It's evolutionary scientists think that. But the Lord, we don't know exactly, we weren't there, but it says he thought it, said it, and got it, which seems like, bam, super fast, instantaneous. Wouldn't need, probably not that old, maybe just a few thousand years old. Anyway, we'll talk about that in a few weeks. Number 3, the sun is a star, D as in Delta. 3, D as in Delta. Number 2 was D as in Delta as well. Number 4, planetesimals collide, and it's C, solar system. It's the evolution idea. Jesus spoke the solar system into existence. But we'll go with the book and evolutionary ideas for now on these worksheets. 4C as in Charlie. Number 5 is 1AU, astronomical unit or AU. Number 6 is a sun. The sun contains almost 100% of the mass or matter in the solar system. Number 6, sun. Number 7 is moon. All but 2 planets in the solar system have a natural satellite or a moon. Number 8, the 4 outermost planets in the sun's orbit are mostly made of liquid and gas. Gas. Number 8 is gas as well. 4 outermost planets in the sun's orbit are mostly made of liquid and gas. Woo! I just did that. Come on, Mr. C, get it together. 8 is gas. 9 is Pluto. Once thought to be the 9th planet, now a dwarf planet, Pluto. Number 9, Pluto. So 8 was gas, 7 was moon, 6 was sun, 5, 1AU. And number 10, the solar system began to form as gravity. No, but that's the book evolutionary answer. Sun formed when God formed it. Okay, number right over 6 again, if you've got all the page numbers. If you don't, I'll sort it out. Mark any that you had wrong. Okay. I want to show you this again. You remember that this was an extra credit opportunity on, this is Exploratorium. Here it is. Exploratorium. Remember, put your weight in and then click on calculate, and beside all of the weights, put down the weight it would be if your weight was 100 pounds. So then go back and put 100 pounds in and then calculate it and put a second answer beside each of those, including the moons of Jupiter and different kinds of stars, if you want 15 points. Get it in the next couple of weeks. Okay? think you might enjoy it. Okay, so wanted you to see that, and then I want you to see this. Again, this is the Perseverance rover. Boop, right there. It's not on the surface of Mars yet. It's on the way. It'll get there in February. So pretty cool. And then, I'd like you to see this. I'm getting there. Okay, inner and outer planets. I'll refer to this in a little bit. Inner and outer. Look at Mars. Now, I keep telling you, Mr. C, quit being really picky about Mars. Well, look, scientists call Mars the red planet. That's red. It's not red. This is orange. I'm maintaining that it ought to be the orange planet. Mr. C, it's kind of in between. Okay, maybe. So orangish red, but not red. It's not the red planet. So anyway, Mr. C, you're being a little too picky. A little too picky. All right, I want you to look at, either have a highlighter, a red pen, I don't care. But I'm quickly going to tell you one more time what is on your test on Friday. You know how I like on Wednesday to start going over what's on the test. So here we go. And then I want to tell you some things about the outer planets. And I want to show you them really quick. They are beauteous. Beautiful. Okay, so first on LS9. I think you've done this already, but I want to make sure everybody's on the same page, including you RLO people. Okay, so you've got LS9 out. So LS9 is out. And you RLO people, you can download these and print them. You must. Okay, on LS9, vacuum. So circle vacuum, circle microgravity. That's it. That's all I want you to know on LS9. LS10, circle geocentric and heliocentric. This is LS10. I'm giving you time. Circle geocentric in the top box, heliocentric in the bottom box, and then ellipse and Galileo. It's not focusing really well, is it? So in the bottom box, ellipse over on the right side, and then Galileo. And Galileo, the idea is he's responsible for the heliocentric idea. Okay, of course, I'll ask you the my vary. There's the my vary. There, right there. My vary. So I'm going to ask you my vary. All right, LS11, I'm going fast. I have to. Okay, just what makes up the solar system, all of those things that make up the solar system. Highlight, this is LS11, sun, planets, moons, some smaller objects like comets, asteroids, meteoroids like meteors, meteorites. There's an AU right there. My finger is pointing to it. Astronomical unit. Of course, I'll ask it. And then what a planet is that goes around the sun, of course. What a planet is. Okay. And then down at the very bottom, I've circled it in red. Down at the bottom right there. There it is. Comets and asteroids. Okay. Now I'll show you all of these. You see I crossed out the bottom box. Woohoo! Nothing in the bottom box on LS11. You saw astronomy up there. at the top, astronomy. Scientific study of space and the objects in space. Okay. All right, now on the inner planets, you've got all the data on the inner planets. So I'm going to give you, what I'm going to do is I'm going to give you probably a match on those, and I'll say things like, which one is the hottest planet? And you'll say Venus. Which one is the smallest planet of the inners? You'll say Mercury. Okay, so that kind of thing. Which one has a very strong greenhouse effect that traps heat? Venus. Yeah. Which one is orange? Because it's got iron oxide in the soil, rusty iron. Mars. Okay. So all of the key things that you wrote about the planets, you were supposed to write all your data there or in your journal. So all of that data is up for grabs. And then the characteristics of the inners, which you just did on your quiz. Small, rocky, slow rotators, fast revolvers, or solid, rocky, solid, few or no moons, no rings. Okay? So all of that. And then now on LS13, the outer planets. What do they have in common? And I have enough time to do this. The outer planets. And aren't they gorgeous? And here they are, the outer planets. Jupiter. And if you'll notice, all of these, it's hard to see, but they all have gas bands. They're all made of gas. They're all huge. Jupiter's the biggest. Jupiter has the most moons along with Saturn. They're tied with 60 plus. Okay? Now I want to tell you something cool about Saturn, and then I'll come back to it in a little bit. Saturn has its really cool rings, but when you look at the rings of Saturn, you can't tell what they're made of. They're actually made of individual rocks and ice. I'll show you in a minute. And then I want you to see Uranus. Look at Uranus. Can you see the really thin rings of Uranus there? It has very thin rings. Now here is the kind of major cool thing about Uranus. Most of the planets are in this plane like this. So they rotate like this. Most of the planets. What's this? Here's Uranus. Uranus is tipped over 90 degrees, so it's up and down. And it rotates like this, from top to bottom, like that. Isn't that weird? By the way, it's proof that God created the solar system, because if they evolved, they would have all been thrown off in the same plane, in the same way, and would all rotate like that. Not Uranus. Uranus is tipped, so it would be like this. Sorry, it would be like that if it were normal, but it's tilted like that and rotates like that. And the rings are up and down. Isn't that weird? And then Uranus is light blue, and then Neptune is dark blue. That's a pretty accurate color of Uranus and Neptune. Okay. Show me on your hands what is the unique thing about Uranus. Show me on with your hands. Everybody, right now, Mr. Gilbert's watching. It's tipped over 90 degrees, and it rotates up and down like that, or up and down like that. Okay? So, and all of the planets have storms, high winds, so like hurricane winds. So, and they're the outer two, Uranus and Neptune, are extremely cold. Extremely cold. Okay, those are the outers. So, and the timing is really good. Here's LS13 right here on the outers. So, I want you, as you study tonight, what's your homework tonight? To review LS9 through 13. And I want you to highlight the bottom box, actually the top box as well, of LS13. So I want you to highlight it, go over it. They tell you, I can see it right there, they tell you about Saturn, they tell you about Uranus, they tell you about Neptune, dark blue, Jupiter the largest. Okay? Mr. C, were you going to show us the rings of Saturn? I'm going to try here. See if I can. Here's what the rings of Saturn are really like. Look at this. Here's what they're like. See that? They're made of individual chunks of rock and ice. Those are rings. Up close, we can't see them from far away. Whoop, little higher, there you go. The rings of Saturn, made of rock and ice. Did you note that? So on LS13, did you note what the rings are like? Did you? Okay. So I went a little bit long today, but I think we're okay. Your homework, remember, is to review LS9 through 13, highlight 13, and just check out those things I told you about Jupiter, Saturn, Uranus, and Neptune. Mr. Gilbert's going to ask if there's any questions, anything to catch up on in your notes, anything that needs to be clarified. Okay, so I'm going to turn it over to him. I'll do a thorough review tomorrow, and then besides that, tell you and show you some of the smaller objects that are in the solar system: comets, asteroids, meteors, meteorites. So that's the plan for tomorrow, and then a test on Friday. Okay, Mr. Gilbert.